decisions are made based upon data analysis. It is said that the amount of data in the world doubles every 2 years as more information becomes available. The challenge that we face is how to extract useful insights from this data. How can we use this data to make better, more informed, accurate decisions? One of the ways that we can better utilize this data is through data analysis, of course. Data analysis helps make sense of this mass amount of data by extracting useful insights from the data. At the end of the day, everyone can benefit from learning more about analyzing data. Let's find out more about the start of our data analyst journey. Lesson 1 will be your intro to data analysis. In Lesson 1, we will learn more about what exactly data analysis includes and why this is one of the most important skills to master today. Then we'll learn more about data itself. And lastly, we will do a fun practical example where we will import and clean data all the way back from the Titanic. Welcome to Lesson 1. Let me introduce you to data analysis. Data analysis is the process of investigating, cleaning, transforming, and modeling the colossal volume of data that is available today. Why do you want to do this? To extract useful information and make more informed decisions. Statistician John Tukey defined data analysis in 1961 as procedures for analyzing data, techniques for interpreting the results of such procedures, ways of planning the gathering of data to make its analysis easier, more precise, or more accurate, and all the machinery and results of mathematical statistics which apply to analyzing data. Data analysis can be looked at as a journey, where with each step, you get to know the data a little bit better. The first step on this journey is when you're introduced to the problem. Here we might be asked by a business to help with an issue they face, or we might have a question about a problem and we want to use data to solve that problem. We want to understand what the stakeholders need in this step of the journey. What needs to happen before you can dive into the data? We need to understand what stakeholders want from the data. And then we need to understand the question that the stakeholders is posing to us. Ways of doing this would be to ask specific questions. For example, which channel should we focus on more to raise revenue? Remember, it is your responsibility to mitigate what you're capable of or what is possible with the data available and how long it will take. It should not take months to analyze, but it is important to give yourself enough time in order to avoid mistakes. Set realistic expectations with the data available and calculate how much time it'll take to analyze the data. Now that we are aware of the problem we face, we need to decide which of these questions that need answering is the most important. First, identify what the questions are that you need to answer. What are your goals? I always like to create a list of my tasks and then assess the importance and urgency of each. How would the stakeholder measure the value of each question they need to answer? Are there any tasks that are quick wins? Open communication about the process with a stakeholder is key, so be open to any changes they might want. Once you've decided upon which question to tackle first, you need to decide on which tools will help you achieve your goals. There are many different tools to utilize for data analysis out there today. It is always better to master one before moving on to another. But by understanding the complexity of the data analysis you want to undertake, you can choose the best tool suited for your needs. During this course, you will learn more data analysis through the tools Excel, R, and Tableau. Excel is the traditional tool for analyzing data and where we will start our journey. In this course, I assume that you have some prior experience with Excel, but if you have never been exposed to this tool, rather head to Shaw Academy's Excel course first to get more acquainted with this tool. Excel is a part of Microsoft Office Suite. It is a great tool for analyzing data, especially if you want employees of various technical skills to analyze data. But it is just one of the many tools that are available in the Data Analysis Toolkit. We don't have to rest all our expectations on Excel alone. R is the next tool in our toolkit for this course. R is an integrated suite of software facilities for data manipulation, calculation, and graphical display. What's great about R is it is open source software, meaning it is freely available for anyone to use, but more about this later. R is one of my favorite tools to analyze data with, and it has some of the best data manipulation, data visualization, and result reporting capabilities. We'll cover R in more detail in Module 2 and 3, so stay tuned for the exciting journey that lies ahead. Tableau is the last tool we will use to our advantage in our toolkit. Tableau is free for students. We'll end our journey with Tableau and explore this tool more in Module 4. The next step in the data analyst journey would be to ask yourself, where does the data come from? Are we using everything available to draw insights from? That is, all possible data sources available? If you're combining several different data sources, it might be good to think about setting up ETL service. If you're combining several data sources, it might be good to think about setting up an ETL service, but more on this later. When thinking about where the data is sourced from, we need to consider what the quality of the data is. In the case of medical tests, we could perhaps investigate the percentage of false positive to false negative tests we receive, meaning we would look at how sensitive the tests are. This step can also look at when the data was recorded. Is your data relevant to today or is it outdated? We could consider some basic data cleaning in this step by adding in more fields like unique variables in order to create new cumulative variables to investigate. To check the quality is very important because herein lies the foundation for analysis. So if the data is incorrect, you will draw conclusions that are incorrect. Now we get to analyzing the data. First, we will need to decide which technique is the best one to apply. Then it is also very important to list any limitations. Limitations include any uncertainties you might have or any unknowns that you've encountered. It could also include missing observations. The last step in our data analyst journey will be to carry over the learnings. In this step, we will report or present our findings. We will have to decide what is the audience that we are catering for. What are the technical skills that the audience have? And how much time do they have? What type of visualizations will we use? We will discuss more on visualizations in Lesson 2. What is interesting about what we know about data analysis and how we utilize the skill today, that is digitally, is that before computers, a US consensus of 1880 took over 7 years to process the collected data. A machine capable of systematically processing data recorded on punch cards was luckily invented that cut down this time, and the 1890 consensus was done in only 18 months. A turning point in the field was reached when relational databases came into being in the 1980s, which allowed us to analyze data on demand through SQL. This speeded up the process of using data to draw insights from everyday use, and gradually more computational techniques led us to what we know as data analysis today. The concepts of data analysis will always have its roots in statistical analysis. But as computational techniques evolve, the two become more integrated and requires a data analyst to have an understanding of the statistical techniques involved, but also to be able to utilize these computational techniques to extract insights from in hopefully less than 18 months. Changing technologies ensure that data analysis is ever-changing and a lifelong journey of learning. Is data analysis for me? What a silly question! Data analysis is for everyone. It's a skill that you can use to better understand data in your everyday life. But it's also a skill that can be used by a business to draw insights from the data they have available and use those insights to make better data-driven decisions to aid their business. Data analysis has become synonymous with problem solving. It can impact the way a business serves its customers. Because of the growing skills gap, analytical skills such as data analysis has become integral to not just technological companies, but diverse industries such as insurance, marketing, product management, customer experience, and many more. In order for businesses to stay competitive, it has become essential to analyze data and find meaningful insights to use for better decision-making in the business world. Choosing to follow a data analysis path places you at the forefront of the decision-making process in the company. Pursuing a data analyst career allows you to choose between a variety of industries, and the high demand for the skill places the role as valuable analytics is everywhere, which means that the new opportunities in this sector are constantly cropping up. It's a hugely exciting time to be part of this industry and start a career in analytics. You are in the right place. There is no doubt that analytics will continue to be a huge part of enterprises in the years to come. So without delay, let's get you started on the road to analyzing data. I know that we're not all familiar with this field, and I want you to be comfortable with each and every aspect of it. So let me take a step back and answer the question, what is data? Data are observations or measurements, unprocessed or processed, represented as text, numbers, or multimedia. For example, the height of Mount Everest is considered to be data. This piece of information informs the mountaineer how they can prepare to ascend the mountain. A data set is a structured collection of data generally associated with a unique body of work. A database is an organized collection of data stored as multiple data sets that are generally stored and accessed electronically from a computer system that allows the data to be easily accessed, manipulated, and updated. We manipulate and investigate data from the data set that is stored in the database. Qualitative data is not numerical data. It can be collected through interviews or focus groups. It's usually collected through open-ended questions. Qualitative data is also subjective, and it is used to generate hypotheses. But we will discuss this later in the module. And lastly, it is used to answer the why. Data can also be quantitative. We will investigate quantitative data throughout. The school's quantitative data is numerical, meaning it is based on numbers. The sample size is usually bigger than it will be for the qualitative data. We use statistics to draw conclusions from quantitative data. Quantitative data is also subjective. The questions that we ask to gather this type of data is closed-ended, and we use this type of data to validate our hypothesis. Upon further investigation, we will subject our quantitative data to being discrete or continuous. But more on this in relation to where do we use data. As mentioned previously, we use data in a vast array of industries to help make better decisions. These can include scientific research, businesses, finance governance, nonprofit organizations, and many, many more. Where do we use data? As mentioned previously, we use data in a vast array of industries to help make better decisions, like scientific research, businesses, finance, governance, nonprofits, and any other organization you can think of. They use data. As a data analyst, you will analyze and report findings back to the industries that have collected the data. Where is this data stored? A data analyst will use databases to access data. A database is a collection of information that is organized and easily accessible, managed, and updated. Data can be stored in some of the following files: Excel or comma-separated value files, text files, XML files, and JSON files. Data can also be stored in databases. Some of the different types of databases available today include a relational database, which is a collection of information that organizes data points with defined relationships for easy access. In the relational database model, the data structures, so the data tables, indexes, and views, are separate from the physical storage, thereby allowing administrators to edit the physical data storage without affecting the logical data structure. Then we have a distributed database. A distributed database is a collection of multiple interconnected databases, which are spread physically across various locations that communicate via a computer network. And then we get the object-oriented database. An object-oriented database is a database that subscribes to a model with information represented by objects. And lastly, we have the graph database. Now, a graph database is designed to treat the relationships between data as equally important to the data itself. It is intended to hold data without constricting it to a predefined model. Go have a look at the technology course if databases pique your interest. It has much more exciting information on databases. Where can you get data from now? In the 1980s, Richard Stallman started what can be seen today as the open source movement. Part of this movement includes open data, in line with open movements like open source and open hardware to make these tools and data free and easy to access. It is so important because data grows exponentially every day. But if there are restrictions, businesses and governments will not be able to become more data-driven in their approach. Or that is the idea. On April 15, 1912, the largest passenger liner ever made collided with an iceberg during her maiden voyage. When the Titanic sank, it killed 1,502 out of 2,224 passengers and crew. This tragedy shocked the international community and led to better safety regulations for ships. One of the reasons that the shipwreck resulted in such a loss of life was that there was not enough lifeboats for the passengers and crew. Although there was some element of luck involved in surviving the sinking, some groups of people were more likely to survive than others. Kaggle contains an open-source data set that holds information about the survival of Titanic passengers. Head over to Kaggle and download the Titanic training data set if you want to follow along with me for the final topic of importing and cleaning this data set with the help of Power Query in Excel. Older Excel versions might have to install Power Query, although in general, Power Query should be installed in Excel since the 2013 version, but you might just have to enable it. In your Excel versions, include a set of features called Get and Transform, which provides fast, easy data gathering and shaping capabilities. Use the Get and Transform tab or Power Query to import the previously downloaded Titanic dataset. Just a quick warning, this is a raw dataset, so it does have some missing data. Some of the entries are not there. Remember, data always looks like this in the real world and oftentimes much worse. We will import the dataset now and do some initial data cleaning on it with the help of Excel. Thereafter, we will create some basic pivot tables just to see if there is anything that we missed before we start the next steps of the process. So click on the Data tab at the top of your workbook in Excel and click on Get Data. As you can see, there are many different ways of importing data in Excel. So we will be importing a CSV file. We want to import the Titanic training data set. So here at the top, you can see the delimiter is set as comma. Excel automatically selected it for us, and that is correct because this is a CSV file, meaning comma separated value file. This view only shows us the top 20 rows of the data set, so it is a subset of the data set, not the entire data set. Passenger ID is the unique identifier for passenger survived and tells us which passengers survived. So 0 is for the passengers that did not survive, and 1 is for the passengers that did survive. P class is the passenger class or ticket class. 1 is for first, 2 is for second, and 3 is for third class. Name is just the name of the passenger. Sex can be male or female. Ages is the numeric value indicating how old the passengers are. Sib-SP tells us the number of siblings or spouses aboard the Titanic that specific passenger has or had. Parch tells us the number of parents or children aboard the Titanic that specific passenger has. Ticket is just the ticket number. F is the passenger fare cabin. Cabin is the cabin number. And embarked is the port of embarkation. And there were 3 ports of embarkation on the Titanic. So now we can click on Transform Data if we want to change anything in this data set. And this will take you to a Power Query Editor. On the right-hand side, you can see that the Power Query Editor has already promoted our first row to headers for us. And on the left-hand side, we can see that there are 12 columns in total and 891 unique passengers in this data set of the Titanic. Let's investigate other variables now. When we look at the cabin variable, we scroll a little bit to the right and we look at our cabin variable. We can see that there is a lot of missing observations. Missing data poses a problem because it does not paint a picture of the entire data set. However, a possible solution could be to extract the string or the text value from the cabin variable, so we could split the text and the numeric value from each other. The reason why we're not throwing this variable away, even though there are many missing observations, is because cabin is an indication of where the guests stayed. In other words, if their cabin was closer to the lifeboats. First class at the top decks are A to E, second class D to F, third class E to G. So it makes sense that towards the top, the higher decks or the higher P classes were more likely to survive because they were closer to the lifeboats. Some passengers have multiple cabins listed. I suspect those passengers purchase multiple adjacent cabins. They are mostly next to each other, so odds would be next to each other, evens would be next to each other. And these are mostly first-class passengers. So let's split the cabin column now. So we will click on cabin, right-click. We will duplicate this column. Then we will go to the top ribbon, click on Add Column, and there you will find Extract. And we want to extract the first characters, and we only want to extract the first character. Okay, so now that we've extracted the first character, the deck that the passenger is on, we can rename this column to deck, just to make it more descriptive for ourselves so that we can remember that this is what the variable is. We can also remove this column that we created that was a duplicate. Okay, next, we just want to make it a little bit easier for ourselves when we draw the data into Excel. So we want to know what is the variable value of 0 and what is the value of 1. So what we could do here is create a conditional column. We can call this column survived text. And we are drawing the data from the survivor column. If the value is equal to 0, then the passenger did not survive. Or else, if the value is anything else, so that would be 1, the passenger did survive. Okay, so now we have a column that contains exactly the same data as the survived column, but it'll just make it a little bit easier for us to read when it's in Excel. If we're happy with how the data looks, we can go back to the Home tab, and we can close and load. Now this will draw the data into Excel. So now we have the entire data set in front of us. We have our survived variable and the new survived variable that we created with text, and the variable that we created where we extracted the text from the cabin variable. Okay, if we now select this entire data set and we click on Table Design in the ribbon and Summarize with the Pivot Table. That will create a pivot table for us on a new sheet so that we can further investigate some of the variables. If we drag this new variables of survived text that we created into the rows and values, we can see that there is 891 passengers in total and 342 of them survived. Now, let's do the same for the deck variable that we created. Okay. So we can see this blank is missing observations. So in other words, 77% of the observations are missing for this variable class. Passenger class is a group's variable of a deck variable. It doesn't have any missing variables. The survival results correlated to a class of the passenger might be more trustworthy than those correlated to the deck. But further investigation will be needed to confirm this. If we look at the passenger class variable, we can see that there is 3 possible values that it can take. Sex can either be male or female. Survived, as previously seen, is either a yes or a no, and the variable embarked has 3 possible values that it can take on. So, as you can see in this step of the journey, we are merely getting to know each variable and the data set better. An exercise you can do is to have a look at the rest of these variables. Are there any variables that have a lot of missing data? Let us know what you have found. Before we move into the final core objective for today, let's have a look at what is coming up in Lesson 2. In Lesson 2, we will start exploring data in further detail. We'll learn more about different data types, different ways data can be graphically represented, and learn more about some basic descriptive statistics. Throughout Lesson 2, we'll practice what we learned on the Titanic dataset and dive deeper in the sea of data. Now, last but not least, for our third objective for today, we learn how to import data. We will utilize Excel as a tool for this step, as well as the Titanic dataset. We will also do some initial, as I like to call it, logical checks on the dataset, just to make sure there is no funny business creeping in before we start with Lesson 2. So how do we get the data into Excel? A few ways include the following. To manually copy and paste data into Excel. The problem with this process is that it is slow, it's repetitive, and it's error-prone. This is not a step I would recommend. Another method could be through the use of macros and VBAs to help automate importing processes. Shaw Academy has an Excel course that offers more on this. Head on over there if you're interested in learning more about macros and VBAs. We will use our query as an ethical tool that is available in Excel to import our data. And then we can also use Power Query to import our data set. Why are we using Power Query to import our data? It is a business intelligence tool available in Excel. Power Query is an addition to Excel that helps to manipulate data. You can connect to different data sources and combine and transform them. You're also able to reuse queries, so set up a query once and refresh it when new data becomes available. There's also no coding, but you can use code if you want to write your own. What can Power Query do? Think of Power Query as your extract, transform, and your load tool in Excel. It allows you to extract, so use Power Query to discover and connect to a variety of data sources. It also allows you to transform, so transform the extracted data by, for example, combining or refining it, and then load, to share the transformed data. Remember that the best way to master data analysis is to practice what we did during the course of the lesson. You can download open source data sets and play around with them if you're interested in other sources of information like finance or medicine. And that brings an end to our Lesson 1. Well done on completing this module. We have learned more about data analysis.